This is the second video for September 13th and 14th, and we're looking at changes in amplitude and reflections and how to graph those. I recommend a few things. First, list everything we know about this function. So here we know that because it's being multiplied by 1/3, that our amplitude is going to be 1/3. We also know that because x is not being multiplied by anything, then that means our period isn't going to change, and the parent function period for sine is 2 pi. So this function's period is going to be 2 pi, and we also know that it's going to move to the right pi units because we're subtracting inside the function. And anytime we subtract inside the function, we're going to shift that function to the right pi units. Now, what's happening here, I would recommend, let's start with the x scale, because our period is 2 pi. Let's go out to 2 pi. And then we're going to use basically our same standard scale that we use. I'm only going to put those two in the negative. We have the 4 tick marks just for space reasons. And then the y-axis, we're not moving up or down, but we are going to change the amplitude to 1/3. So I'm just going to say that if this is 1, then I'm going to say 1/3, 2/3, 3/3. 1/3, 2/3, 3/3. Now in graphing these, here is what I am recommending, and we'll do it twice. But what I'm recommending is, here we're multiplying our parent function by 1/3. So that we don't have to draw like 5 different lines for each transformation, I recommend multiplying your parent function, if you will, by 1/3. What do I mean by that is, if you look at the parent function for sine, it usually starts here at 0, 0. I'm going to take the y value, or the output, and multiply that by 1/3. So here starts at, the y value would be 0, 0 times 1/3 is still 0, so it would still be here at 0. Then the parent function for sine usually goes up to 1. But I'm recommending, because I think it'll be easier on the transformations, is to take that 1, multiply by 1/3. 1 times 1/3 would be 1/3. So instead of putting it at 1, because we were going to multiply by 1/3, put it at 1/3. Now we could do similar here. At pi, usually sine goes through 0. 0 times 1/3, that's still 0. At 3 pi over 2, it's usually at -1. -1 times 1/3 gives us -1/3, 0. And then it does a similar pattern here. Instead of going down to -1, it's going to go down to -1/3, then back to 0. Then instead of 1, it's going to go up to 1/3, and then 0. And I'm recommending making this your dotted line because it's not your parent function, but it's a modified parent function. And here's why I'm recommending that. If you look at the things we know, we know the function will have a period of 2 pi. Our dotted line, does it have a period of 2 pi? 0, up, down, repeats here. It does. We took care of that. We don't have to worry about that anymore. Have we shifted to the right pi? No, we still need to do that. But is the amplitude 1/3? By multiplying our function by 1/3, yes, this distance here is 1/3. This distance here is 1/3. We've done that. We don't have to worry about that anymore. So what do we have to do? We take every point and move it to the right pi. Because pi is our second tick mark from 0, all we have to do is move every point to the right 2 tick marks. So this point is going to be here. This point, 1, 2, will be there. I'm going to put an X through those because I know I'm going to use those. This point here, 1, 2, is there. 1, 2, 1, 2, 1, 2, and 1, 2. Yeah, son, look at that. And now I'm going to draw the line, solid line, that goes through those points. And that's our actual function. And we can also talk about its domain. Now that we've graphed it, we know that's going to go forever in both directions. Nothing is undefined for sine and cosine, so our domain is negative infinity to infinity, and our range, the lowest value it now goes to is negative 1/3, and the highest is 1/3. If you have questions, rewind, ask me, please. Feel free to ask any questions. Real quick, let's go through this one as well. Let's see what every value is telling us. Here we're multiplying here we're multiplying by a -3. Because we're multiplying by a value, that's going to change the amplitude. We know that the amplitude cannot be negative, so our amplitude is 3. The negative is telling us that we reflect. I know the shadow's in the way. I'm going to move. Man. Maybe I'll do this here. X is not being multiplied by anything, so our period stays 2 pi. And the +4 on the outside of our function tells us we're going to shift the entire function up 4. So our period 2 pi. I know the shadow's in the way, but it's going to be our standard scale on the x-axis. Our amplitude is 3, which means we're going to stretch our function out by 3, but we also need to move up 4. So because our amplitude is going to be 3 and move up 4, we need to go up to at least 7. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And now I recommend doing the exact same trick. Usually sine is here at 0, 0. 0 times -3, because that's what we're multiplying our parent function by, is still 0. Then sine usually goes up to 1, but we're going to take 1 and multiply by -3. 1 times -3 would give us -3. 0 times -3 would give us 0. Usually at 3 pi over 2, the function goes to -1. But we're going to take that -1 and multiply by -3. So it's going to be here at 3. And then at 2 pi, it's 0 again. 0. Because 0 times -3 is 0. It's going to follow a similar pattern. It's going to go 0, 3, 0, -3, 0, 3, 0, -3, 0. And again, I recommend making this your dotted line, because this is our modified parent function with some things changing. Let's take a look at what changed. First is our period 2 pi. Yes, we made our period 2 pi by the x scale, so we don't have to worry about that anymore. Have we reflected? Well, usually here, let's think about that. Sine's here at 0, then it usually goes up and then down. But here it's going down and then up. So yes, we have reflected, and our amplitude, this distance here and that distance there, is 3. So by multiplying by this -3, we can take care of any reflections that we have and amplitude changes. But we have to multiply our parent function, those key values, by that value in front of sine or cosine to actually take care of that. What do we have left to do? Shift everything up 4. So we take every single point that we have and move it up 4. 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 4. And then this is our actual function. Again, multiply our parent function by this value. That's going to take care of our amplitude and reflection. If you have another way of thinking about it that's correct, please feel free to do so. I just think this is a way that makes sense in my brain. If you have questions, please feel free to ask. Recommend you doing the domain and the range here, and try number 3 and 4 as well.